welcome to the wonderful world of organic chemistry. This is going to be an introduction to grade 12 material, and it's mainly focused on how do we name organic compounds. So, organic chemistry revolves around compounds that contain carbon, and that's because carbon is very abundant in our world. It is very special because of its high bonding capacity. So we know from grade 11 chemistry that carbon has 4 valence electrons. And that makes it special because it can actually have up to 4 bonds with other elements. And usually this is going to be with hydrogen. So when we have a carbon atom, or let's say a carbon chain, a bunch of carbon atoms bonded together, and those carbon atoms are surrounded by hydrogen bonds, we have what's known as a hydrocarbon. And so the material for grade 12 is really going to focus on all different types of hydrocarbons. So down here, I have a few representations of the same hydrocarbon. All 3 of these are representing what's known as pentane. Don't worry about the naming yet. I will go over that very soon. But just as a preview, you may notice that pent or penta can represent 5. And if we were to count the number of carbons in this carbon chain, we have 5. And so that's where the name comes from. In this first representation, I've clearly got all of my carbons shown, and then I've individually shown every individual hydrogen bond around each carbon. In my second example, this is what's known as a structural formula. I'm basically showing the same thing. I'm showing every individual element that's part of this compound. I'm just not really showing the lines that represent each bond. Instead, I've kind of put elements into groups. So this first group of CH3 is showing our first chunk of our hydrocarbon. Then I have 3 groups of CH2, and if I go back to the first drawing, I can clearly see those 3 groups of CH2. And then finally, to sandwich everything together, we have a CH3 at the end. So both of these drawings or formulas are perfectly valid, but I actually want to focus on our third example over here, which is a line diagram. And it's probably pretty self-explanatory as to why we focus on these kinds of diagrams. They are a lot simpler, but we need to understand how just a few simple lines could somehow represent everything that's going on in hydrocarbon. Because this too is also representing pentane. So let's take a closer look at the pentane line diagram. So how are we showing all of the carbon and hydrogen bonds with just this simple diagram? Well, every end point of these individual line segments actually represents a carbon atom. And that's how I can represent 5 carbons in the carbon chain. And if I look at my prefix table, if I want to represent 5 carbons, I need the pent prefix. And what we're actually dealing with in this introduction, to start with, are what's known as alkanes. And alkanes are hydrocarbons that only contain single bonds. And that means that we are able to completely saturate the hydrocarbon with hydrogen bonds. So we're not actually drawing all of these hydrogen bonds when we do our line diagram. We're just assuming that all of this is happening based on these small line segments that we draw. But since we're dealing with alkanes, that's where this suffix comes from, which is why the name of this carbon chain is pentane. Let's try a few other examples. Let's start down here. And if I count the ends of my line segments, I have 3 carbons. Looking at the prefix table, 3 carbons would be represented by the prop prefix. So we have what's known as propane. And that is in fact the same propane that you would find in these kinds of gas tanks connected to barbecues. Let's move on ahead to this one. If I were to count my carbon chain here, I could kind of count like this. So 1, 2, 3, 4, 5 carbons. But it looks like there's a weird branch sticking off of my second carbon. And so we need to think about how we're going to deal with this lonely carbon chain over here. My first order of business is to just count the largest continuous carbon chain I can find in the diagram. That appears to be 5. So I know the main naming for my hydrocarbon is going to be with pentane. And then if I want to show this branched carbon on my second main carbon, I'm going to use the meth prefix because this is the prefix associated with 1 carbon. So I'm going to say methyl pentane. This ill ending just references the fact that we're not looking at the main carbon chain, we're looking at a branch. And then finally, I need to specify where the branch is branching off from our main chain. It's branching off from our second carbon, so I'm going to say that this is 2-methyl pentane. Don't worry if the naming seems like a lot right now. With repetition and practice, you'll definitely get the hang of it. Let's try this next one. It looks like, once again, we have a main chain of 5 carbons. So this is a pentane, but we now have actually 2 methyl branches. And what I could do is I could count things out from left to right for my main chain and say that I have a methyl group on carbon 3 and carbon 4. However, that is not the best way to number this hydrocarbon. I want to make the numbers associated with my branches as small as possible. So if I actually start counting the carbon chain from right to left, you can see that we now have a branch on carbon 2 and carbon 3, which are lower numbers. So that is actually a better way to look at things. If I have 2 of the same branch, I'm just going to put a di prefix in front of the name. So I have a dimethylpentane because I have 2 methyl groups. Now all that's left is talking about where they are. Since I have 2 branches, I just need to specify those 2 numbers before the actual name. So this is 2,3-dimethylpentane. All right, let's introduce some new ideas here. We're now going to be looking at branches that are not carbon. So we're still looking at hydrocarbons. They just may have some unique branches. And these branches are actually called halides. So we can have chlorine, bromine, fluorine, nitrogen dioxide, or iodine. And let's see how we can name them. Let's look down here. We are going to start off the exact same way. We want to count our largest carbon chain. And if I start counting from left to right, this branch here, our chlorine, would be on our third main carbon. But if I count from right to left, it would be on our second. And we just learned that that would be much better. So 4 carbons together is going to use the ending of butane. I don't think you're going to get this prefix table on a test, so it is going to be very useful to memorize it. So 4 carbons is butane. And if we want to talk about a chlorine branch, we can see up here that we need to use chloro to name it. So I could say we have a chlorobutane. And then I just need to remember to specify where this chlorine is on my main branch. So we have a 2-chlorobutane. Next one is a bit more complicated. Let's see what's going on here. Immediately I can tell that if I count from right to left, I should have the lowest numbering. So let's do that. And this time I have 7 carbons, and the prefix for 7 will be hept. So we have a heptane. I have a iodine branch on carbon 3, and excuse me, a 2-carbon branch on carbon number 4, and 2 carbons based on our prefix table is going to be referred to as an ethyl branch or an ethyl group. So I need to put both of these branches in my name, but if I look at this rule over here, it states that when you have multiple chains, they have to be written in alphabetical order. So you might think, okay, the iodine comes first because it's on carbon 3, so I'm going to write iodine as my first branch. But since ethyl comes before iodine when looking at the alphabet, and it's embarrassing, but I often have to go back to the alphabet song to remember my alphabetical order, but that's always useful if you need it. E comes before I, so I'm actually going to write 4 ethyl, 3 iodo, because that's our naming for iodine, heptane. So heptane is my main chain, and then I have my 2 branches in alphabetical order with their placement on the main chain. Okay, one more before we move on. This one looks like I can't just start counting from left to right, because if I did that, I would have 1, 2, 3, 4, 5, 6 carbons. But if I actually start up here, I would have 1, 2, 3, 4, 5, 6, 7. So it's actually better to count with this line segment up here as part of my main chain to show that I have some form of heptane. And once again, I can see that if I were to count from right to left, that should minimize my numbering. So I have a bromo branch on carbon 2 and a methyl branch on carbon 5. So this is going to end up being 2 bromo, 5 methyl heptane. Hopefully it's coming together for you. We just have a little bit more to add. So as I mentioned earlier, up until now we've only been dealing with alkanes, but there are cases where we're going to have double or triple bonds between carbon atoms. So when we have a double bond, we have what's known as an alkene. So instead of the ane ending, we have ene. And if we have a triple bond between carbon atoms, we have what's known as an alkyne, and it gets the yne ending or suffix. And you can understand why a alkane is considered a saturated hydrocarbon, because if carbon only has a single bond between it, or between two atoms of carbon, we can have as many hydrogen bonds as possible. But if we have a double or triple bond, that number of hydrogens that we can bond to with respect to carbon has decreased. Now, in terms of how we're going to name things, it's pretty much the same. We just have to consider where the bond is occurring with respect to our main carbon chain. So we're going to have to add a number at the end of our name based on where the double or triple bond is located. So our first example has a double bond, and I can see that based on this parallel line to one of my carbon bonds. So this right here is what a double bond looks like. And just like branches, I want to give my double or triple bond the lowest possible numbering in my name. So to do that, I want to count from left to right. I definitely have something with pent in it because we have 5 carbons. But I want to add a number to represent where my double bond is in the hydrocarbon. So I'm actually going to put the number before the suffix. So this would be pent 2e. I have seen some teachers teach this where you put the number before pentane, or I guess I should say pentene, as we're dealing with a double bond. So I'm pretty sure this is fine in terms of naming. I just prefer the first way because you're directly connecting the number to the part of the name that's referenced in the double bond. Okay, let's move on to triple bonds, which we have over here. And this one's going to be a little bit different in terms of how we count our carbons, because when we have these 2 parallel lines next to our main carbon bond here, or carbon line that represents the bond, we actually have a carbon at each end of the shorter line segment. So if I counted out all the carbons in my main chain, I would have 1, 2, 3, 4, 5, 6. So be very careful when dealing with triple bonds. You don't want to forget to count the 2 carbons that are represented on this smaller line segment. So we're actually dealing with a hex prefix to have 6 carbons represented. And since our triple bond starts on our second carbon, this is going to be a hex 2 ine. All right, one more example. In this case, we have an iodine branch, and we also have a double bond. If I count my main carbons from left to right, this would be on my second carbon, and my double bond would start on my fourth carbon. So you might be thinking, okay, if we're trying to minimize the numbering in our names, that would be ideal. Because if I tried to count from right to left, sure, I would have my double bond on carbon 2, but I would have my iodine on carbon 5. However, in this scenario, the double bond is going to get priority. and that's super important. Double and triple bonds always get priority in terms of getting the lowest possible number. So in fact, we are going to want to number things from right to left. I have 6 carbons, and my double bond is on my second main carbon. So we definitely have a hex 2-ene here. And then in order to represent my iodine on my 5th carbon, I'm going to say 5-iodo-hex 2-ene. Honestly, I don't know if my pronunciation of alkene and alkyne is correct, so I apologize for that. But just focus on the suffixes in terms of being able to differentiate when we're dealing with double or triple bonds. Okay, that's going to be it for today. Hopefully you found this useful. The name of the game with organic chemistry is definitely to practice as much as you can. And if you would like more practice, I highly recommend this website, chemquiz.net/org. That's for organic chemistry. And here you can basically create a custom quiz for naming hydrocarbons. So let's say I wanted a quiz with 10 questions, and we've only gone over naming compounds, so let's focus on that. And what the heck, let's have up to 10 carbons in our main chain. We've looked at alkanes, alkenes, and alkynes, so let's leave all of that. We haven't looked at this. These are called our functional groups, but that will be covered in a later video. Halides would be good to look at. Let's get rid of that. And I don't want the chemical formulas. So now it's going to generate me a quiz that I should be able to work out. So these are very similar to what we just did. They're probably going to be slightly more difficult, but by following all of the rules that we just covered, you should have a really good understanding of how to name these compounds. So, thank you so much for watching, and good luck studying.